In today's video, we are going to talk about how to use Kubernetes pods as Jenkins agents. You've been thinking about how to use Kubernetes with your Jenkins setup, but you're not really ready to go all in on Kubernetes yet. So maybe, just maybe, your next right step is to use Kubernetes as your agents. But then you think to yourself, I'm not a Kubernetes administrator. I've never even set up a Kubernetes cluster before. How am I going to do this? Today, we're going to walk through an example using even my local machine where I have a Jenkins VM running inside of a Vagrant box, and I've got a local Kubernetes cluster based on kind. So all I have is Docker Desktop, and I'm able to go ahead and run this and show you these examples today. If you have Docker Desktop, you should be able to follow along with these examples. So here's today's starting point. As I've already said, I've got a Jenkins controller version 2.289.1 running on a VM. It's actually a Vagrant box. And I also have, wait for it, no agents. That's right, you heard me right. There are no static agents involved in today's video at all. But what I do have is I have a Kubernetes cluster, or to be more precise, we're getting ready to have a Kubernetes cluster. I'm going to walk you through how to set up a kind-based cluster on your machine while using Docker Desktop. All of the commands that you see me run today are going to be in a gist, and the link for the gist will be down in the description. To get started with, I'm setting up a configuration file today to help configure my kind cluster with a specific IP address and a specific port. Now, the IP address that I'm using is the IP address of my machine. Without an IP address, it's just going to listen on localhost. And in order for my controller to be able to connect, I need to have a routable IP address. Now, the port, I'm just setting to make it easier so I can track it. If you leave the port out, then it will just give you a randomly assigned port. So I'm just assigning a port that it gave me at some random point in time. But the configuration file, let's take a look at that configuration file real quick. I have a file named Jenkins-config YAML, but it's really for kind, but you get the drift. And it's actually really short. I have a kind cluster. I have API version, that's the specific API version. And then for networking, I'm setting the API server address to my local IP address, which in my case is 192.168.1.19. And then I set an API server port just to 58.350. You can make the port whatever you want it to be. Again, if you leave this line out, it'll just give you a randomly generated port. I just wanted to know what the port was so I can make my notes a little bit easier. Okay, now we're ready to start our cluster. Here's what we need to do. We need to do kind create cluster, and I've already installed the kind CLI. That came from, I'm on a Mac, so I installed it through Homebrew. There's numerous ways to download kind. Again, you need Docker Desktop. And I'll make sure that the documentation link for kind is also down in the description. But I'm doing kind create cluster, and I'm doing config Jenkins config YAML. Let's hit enter. See what happens. So it's starting up. It's a single node cluster, much like Minikube. So it's going through, starting up the control plane right now. It's getting the worker node squared away. Everything's going along fine. It takes just a couple of minutes. And now our Kubernetes cluster based on kind is running. So let's check it out. I'm going to use the cluster with Kubernetes cluster info context kind. Let's see what that does for us. It gives us some data, and the data primarily is it's validating that we're running at this IP address, which is what we defined in our config YAML, and also the port. This information is going to be important once we start setting up our Jenkins controller. Now, let's go on over to our Jenkins controller and start getting things ready to connect to this Kubernetes cluster. First thing I want to do is I want to eliminate all of the executors that are on the controller. So I'll just click on Build Executor Status. That takes me over into the Nodes section. I'm going to click on Master, and then I'm going to click on Configure. I'm going to change the number of executors to 0. The label, I'm just going to make up some random characters, and I'm only going to use it when it matches that node. Again, you can watch a previous video where I go through all of these settings. Click on Save, and now we can see that there are no executors available on this controller to do any kind of work. Now, in order to use a Kubernetes cluster as our agents, we have to install one plugin, and that plugin is the Kubernetes plugin. So let's go over here to Manage Plugins, go to Available, and then let's search for Kubernetes. And it's going to be the top one that says this plugin integrates Jenkins with Kubernetes. So at the time of recording, this was 1.30.0. I'm going to click on Download Now and Install After Restart. And you can see that this Kubernetes plugin carries along another 5 plugins as dependencies. So let's wait for these to be installed. Okay, now that we're back up, let's go ahead and log back in. And one thing you're going to see here, once we go back over to Manage Jenkins, is we can go to Manage Nodes and Clouds. But what we want to do now is click on Configure Clouds. And underneath there, we're going to click on Add a New Cloud and select Kubernetes. Now by default, the name that it gives it is Kubernetes. As we go through our example today, if we were to give this a different name, such as Kubernetes kind, we would have to change our job to point it at this specific named cluster. If you leave the cluster name just Kubernetes, then the defaults within our Jenkins files will just assume that the Kubernetes name is Kubernetes. Now, in order to configure the plugin, we need to click on Kubernetes Cloud Details. We need to give the Kubernetes URL. Now, if we think back to what we saw here just a moment ago, our Kubernetes control plane is running at this address. So let's go ahead and copy this and move back over to Kubernetes URL and paste that in. If you go ahead and scroll down to the bottom, sort of, towards the bottom, you'll see a test connection. Let's go ahead and click on test connection and see what we get. We can see here that there's error testing connection on HTTPS. Well, that sort of makes sense, right? Because it's unable to find a valid certification path because that is a self-signed certificate. With Kind, you can use real certificates, but in my case, I didn't set one up. So what I'm going to do is I'm going to check Disable HTTPS Certificate Check. Now, in a real production environment, or even in a lower environment, you probably would not want to do that. But for this example, I'm okay turning this off. So I've checked Disable HTTPS Certificate Check. Let's go ahead and click on Test Connection one more time. Now we can see that error testing connection, and it's forbidden by System Anonymous, so we have not created any credentials yet, that we cannot list pods in the default namespace. So there's two things popping out here right now. First off, we're trying to connect to this cluster as anonymous. That's not allowed. Secondly, we're trying to connect to the default namespace to list pods. So that means that we're going to need to set up a credential so we can actually authenticate against the cluster. And also, I want to create a specific namespace for all of my pods to start up in. So first off, let's go ahead and create our namespace. And really, that's really simple. If you've used Kubernetes at all, we're just going to use kubectl, create namespace, and we're going to call it Jenkins. So if we were to do a kubectl get namespace, now we can see that we have our Jenkins namespace that was just created 5 seconds ago. Now that we've created the namespace, let's go ahead and go back over to our controller and let's specify our Kubernetes namespace. And we'll just type in Jenkins. Now remember, we have not created a credential yet, but let's see what changes in this error message. So when we click on Test Connection, now we can see that in the namespace Jenkins. So we're pointing it at the Jenkins namespace, but we're still system anonymous. So how do we create the credential that we need? What we need to create is a service account. So here's the command to create the service account. So let's go back over to our shell. And we're saying kubectl create service account Jenkins, just giving it a name of Jenkins, in the namespace Jenkins. So now we have a service account. But all we've done is create the service account. What we have not done is create the credential within Jenkins to use this credential. So how are we going to do that? We need to do one more thing. As we created the service account, there is a secret that is available to us. So in order to get that information, and this command will be in the gist, we're saying kubectl describe secret. So when we did a create service account, a secret was created. And we're getting the secret based on the one for the service account Jenkins. We're going to grep out token, and then we're going to print out the value. And all of this is happening within the Jenkins namespace. So let's take a look at this. What we're going to see is, and in fact, this didn't work really well because this really should be a lowercase t, but that's okay. This is the token that we need. So within this token, I'm going to copy this, and we're going to go back over to our controller, and we're going to add a credential. Now, what type of credential do we need? That's one long string. So that could be a secret text, or it could be a secret file. And then you have to load the file in. But for me, I'm going to use a secret text. So the secret is this. And I'm going to say this is Jenkins kind for the ID. Doesn't really matter. Same for the description. And click on Add. Now let's select this credential, Jenkins kind. And let's click on Test Connection one more time. It is still failing, but it is using that user. And it's an authentication error. So there's still one more thing that we need to do. And what we need to do is create a role binding for that service account. So let's go back over to our shell. Let me go ahead and clear this up. And what we're going to run is a kubectl create role binding, Jenkins admin binding, that's the name. We're giving it the role, the cluster role of admin. The service account is being mapped back to Jenkins, and the namespace is Jenkins as well. So let's hit enter. Now it's created the binding. Let's go back over to our test connection and see what happens now. So now that we have our service account, we have our role binding, we have our credentials defined here, we now see that we are connected to Kubernetes version 1.21.1. Now, so we don't have to go back and forth for a couple things, I'm going to give you one more piece of information. Let's go back to our controller. You'll notice this warning down here. TCP port for inbound agents is disabled within global security settings. If you're used to working with Windows agents or any type of agent that connected from the agent back into the controller, that used to be called JNLP. You may be used to hearing inbound agent, whatever that is. Since the TCP port is disabled, we will not be able to connect from our pod. And this is the key part here. Anytime a pod is spun up within the cluster, it connects back to the controller. The controller is not spinning up the pod and then connecting to the pod. The controller is giving a command to spin up a pod, and the pod has the information to know where to connect back to. So we could go and enable the TCP port, and that would be okay because I have a standalone VM and I could open up that port. But we also now have the option for WebSockets. So in my case, I'm going to connect WebSocket because when that pod spins up, it's going to connect across HTTP in order to make that initial connection and then the persistent connection. Now that we've got all our settings done, let's go ahead and click on Save. There are a lot of other settings here. We don't need to do any of these today. One last thing before we go away and click Save. You'll notice here, this is going to connect using HTTP CC2 8080, which is our Jenkins controller URL. So if for some reason you have an unroutable network by name, so you're not able to resolve, in my case, CC2, then you might have to specify a Jenkins URL. Maybe that's by IP address and port or by name, whatever it may be. But in this case, I know that I'm able to connect from my Kubernetes cluster back to my Jenkins controller using CC2. Okay, let's go ahead and click on Save. And let's go create a job just to test things out. So I'm going to click on New Item, and this is going to be Test Job. Create Pipeline, click OK. And let me go grab my example pipeline. And again, this will be in the gist, so you can just go and copy it directly from the gist. So what we have here, almost have it, there we go. Let's go down here and paste it in. So let's take a look at this. You've been used to seeing pipeline agent any or maybe pipeline label Linux, but in this case we have pipeline agent Kubernetes. And here we are embedding the YAML definition for the pod that we want created. In this case, I want a container created that has the name of Maven, and the image that we're using is Maven:\Alpine. The links for the Kubernetes plugin documentation will also be down in the description, so you can go and understand all the different things that are available to you and how you can use them. So this is just a very simple way of doing it. We've defined the agent via YAML. And within our job, so we're down into our stage with steps, notice how we're calling out container Maven. This name Maven maps back to this name at line 9. So we're saying, okay, in the container of Maven, go and run a shell step of Maven-version. So let's go ahead and click on Save. And click on Build Now. Now, since we just created that kind cluster, the image for Maven doesn't exist. So what we're going to see here as the job starts up is that the image is going to be downloaded from Docker Hub. So we can see that it's pulling image Maven:\Alpine. And since we didn't specify a registry, it's going out to Docker Hub to pull. So we successfully pulled that image. It's creating the container Maven. Now it's also pulling this image Jenkins inbound agent. This Jenkins inbound agent is the container within the pod that is making the connection back to our Jenkins controller. Then you'll notice something here that's very strange, or maybe not so strange. Remember how big or not so big our YAML was? This is the fully qualified definition of the pod that is being spun up right now within our cluster. So we see lots of other information here. Now these can be overridden if you want, or you can specify them in the YAML. This is all up to you. We can see here the limits are pretty small. It's only 250 meg, really small CPU. So there might be times where you need to specify limits. The great thing about seeing this full YAML here is now you have an example of, oh, I actually need to override this. So you could come in here, take this snippet out, and go and put it in your YAML and make the modifications as you need. So if we go ahead and scroll down a little bit more, once we get into Maven version, we can see that we're in the container here. We're run Maven, so this was the container. Maven version, and we can see that this is 361. Now, what I want to do within our pod is I want to go and create another container within the pod. So let's go back to our test job. And since we did Maven, that's typically a back-end thing. Let's go and do a front-end thing, like Node. I know people use Node for back-end too, but go with me. I'm using Node for front-end right now. Now this is YAML, so it's got to be spaced correctly. So let's make sure I get everything in line. Oh, I had it in line. Whoops. There we go. Okay. So here we had our Maven image, our container. Here we have our Node container. So within the pod, we can have multiple containers. First time through, we had our Maven container and the Jenkins inbound agent container. The Jenkins inbound agent container just comes along for free. It's what the Kubernetes plugin injects for you, so you can make that connection back to your controller. Now I'm adding a third, even though there's only two defined, this is now the third container that will be in the pod. So what we're going to do here is go down to our same stage. Again, this is a very simple example. Container node I'm going to say sh npm version. And let's click on Save and Build Now. As it runs, we're going to see that container image Maven Alpine already present on the machine. That's our kind cluster. Then it's pulling the image for node 16, Alpine 312. Container image inbound agent already exists. So notice this time it was a lot faster because we did not have to pull 2 of the 3 images. When we get down into the job, we see Maven version just like before and NPM version right here. Finally, I want to call out one more thing. Within the pod, all of the containers can access the same workspace. So what does that mean? Well, a picture is worth 1,000 words, or in this case, a few lines of code is worth 1,000 words. So what I want to do here is I'm going to say sh echo hello. I'm going to put that in hello.txt. I'm also going to do an ls-last. Then here, I'm going to say cat hello.txt. And just for completeness, I'm going to list out the workspace. So I'm creating a file in the context of this container, but when it's created, it's written out to the workspace. Then when this container is accessed, it has access to that exact same workspace. So let's click on Save and see what happens. Click on Build Now. Let's take a look at number 3. First off, we're going to see that container image was already present for Maven Alpine. Same is true for node. Same is true for inbound agent. So it's all defined. Here's our full YAML. Now let's get into the output here. We can see that in our Maven container, we did an echo hello. And here's our listing, and we see hello text. Then we change containers, and now we're in our node container. And if we take a look after here, here's our cat hello text, and we can see hello. So, and then the full listing within the workspace. So we can see that the workspace is shared between containers within a pod. That's a very, very valuable feature and benefit, because if I needed to be able to pass a file along to a different container, maybe not a full set of files, but maybe just a file here or there, instead of having to use other features to do that, then you're able to just use your workspace to make that file available. Again, make it sure that it's a very small file. Don't put a multiple gig file there. That would probably be a bad idea. But a simple text file to where you just need to give it a little bit of JSON or maybe just a small YAML to pass on down to other containers. This is a way that you could potentially do that. So why would you want to get rid of static agents? Well, the short answer is you might not be able to completely. You may still have some static agents that you need to run, maybe like Mac OS or ZOS. You can't containerize those 2 operating systems along with a list of a lot more. So in some cases, you're going to be stuck with using static agents. But the upside of being able to eliminate static agents is that you don't have any more VMs to maintain. It makes security more happy. It makes infrastructure happy as well, because you're not wasting their resources for VMs that are just sitting around and being used every once in a while. Another reason why using Kubernetes pods as agent is really powerful is it gives pipeline authors the ability to define the tools that they want to use, without you as a Jenkins administrator having to set up the agents with specific versions and maintaining that through Puppet, Chef, Ansible, whatever tooling you're using. They can define within the pipeline, as we saw today, specifically which versions of, in this case, Maven or Node that they want to use. And finally, in theory, and this is a big in theory, you're not going to run into performance or capacity issues when you move to agents running within Kubernetes. Now, the in theory assumes that your cluster is auto-scalable. So if it needs more capacity, new nodes would be brought online so you could continue using your builds. Now, obviously you don't have infinite capacity, but if in the past you've only had a single static agent that your people were using, now you have access to a Kubernetes cluster. They're able to define the tools that they want to use, and they have reasonable scaling capabilities. And then the queue in the Jenkins controller could possibly be eliminated because the jobs are being served in a more timely manner. If you have any questions or comments, you can reach out to us on Twitter at CloudBeesDevs. If this video was helpful to you, give us a thumbs up. And if you haven't subscribed to CloudBees TV yet, why not? take a moment, click on that subscribe button, and then ring that bell, and you'll be notified anytime there's new content available on CloudBees TV. Thanks for watching, and we will see you in the next video.